have you joining us live today. We just finished a little ocean action, and I think it's time we feature a kingdom that maybe doesn't get as much attention as it should, because it's pretty darn important.
It's definitely going to be different.
All right, I love it. So yeah, let me give you a quick little intro, and then I'll let you take over for a little bit. So Anne Pringle spent her childhood traveling through Southeast Asia and West Africa. She was dragged on a lot of birding expeditions, apparently, and abandoned our feather friends for fungi. So she's currently at the University of Wisconsin-Madison, where she is now Vilas Distinguished Achievement Professor in the Department of Botany and Bacteriology, and a National Geographic Explorer as well. Again, Anne, it's a pleasure to have you joining us today, and we're excited to dive into your world.
Excellent. All right, let's see. So I have to, do I have privileges to share my screen? I do. So let me find my PowerPoint. And all right, let me get the slideshow going. All right, I think we're ready to go. So first of all, thank you, Joe, for organizing this. And I know there are other people helping to organize. It's really a privilege to be speaking with you. And it's in the same, can you hear me? Because it's telling me I'm muted. It's good? Okay. I've thoroughly enjoyed the day. I love being included with big cats and whales and oceans and rainforests. And it's true, I'm going to take you on a really different kind of journey now. And if you remember nothing else about this talk, there are two takeaways in these first two slides that I hope that you will remember. And the first is that perhaps in contrast to some kingdoms, most of the biodiversity of fungi and fungal-like organisms is undescribed. So we think we have names for something like 5% of what we estimate to be between 1 and 10 million species. And just the fact that I can't tell you if it's 1 million or 6 million or 10 million species tells you a lot about what we don't know about this earth that we walk. It's also true that that kind of uncertainty, except that we're certain that we don't know a lot, makes it difficult to talk about conservation. So it's difficult to protect undescribed biodiversity. Even a lot of the legislative tools that we have to protect species are about that, right? They're about protecting species. But in this kingdom, in these kingdoms, if we don't have a name for it, maybe we don't even know it's in trouble. It's very likely that things are going extinct before we can even start to think about how to protect them. So just the conversation about conservation, if you will, is radically different. So the first message is there's a lot we don't know. The second message is actually that a lot of these species aren't mushrooms. Mushrooms are really magical and mystical. I love going mushroom hunting. I love finding mushrooms. But there's a lot going on in these kingdoms that doesn't have to do with mushrooms. So here you're looking at a slime mold, and it's doing something that you might not associate with fungi. It's foraging. It's looking for food. It's growing out from one oat flake, and it's trying to find another oat flake. These are just Quaker oats bought from a grocery store, but actually it's probably eating the bacteria that live on these Quaker oats. Anyway, you can see that this organism is growing out. It's making this network. Eventually the network is going to find, yeah, it found its other oat flake, and now it's going to divert resources towards that other oat flake and continue foraging. So it's a really dynamic group of organisms. They do have behaviors. They're really interesting. They're intriguing. There's just a lot we don't know. So it turns out that many of these species are involved in intricate symbioses with other species, including species from other kingdoms. And this really comes to the heart of what I want to talk about today. So when you look at this image, you might be tempted to think that there are a certain number of individuals growing on this rock, and you might want to count them. You can see there's 1, 2, 3, 4, 5, 6, maybe some smaller ones. But it's a complicated use of the word individual. Actually, if you were to cut, and these are lichens, if you were to cut one of these lichens in a cross section and look at it in detail, you discover that these lichens are more like ecosystems than they are analogous to birds, for example, or lions. You're looking at an entity that's made up of fungi and bacteria. You can't see the bacteria, but if you could use molecular tools, you'd right away discover that they're there, and they're arranged in interesting patterns across the body. And there are algae, and these algae they take carbon dioxide out of the surrounding air, and the lichen is really built, the biomass of it is built from air, is built from that carbon dioxide. So in talking about whether these are organisms or individuals or what they are, maybe they're ecosystems more analogous to a forest, for example, or a coral reef. You just get to some really interesting places. And these are questions I've been thinking about for a very long time. How should we think about these creatures that look like things we should count? Are they things we should count? And partly I'm motivated by thinking about conservation, because I think to really effectively conserve systems like this, we need to know a little bit more maybe than we know now. So because I've been thinking about this for a long time, in 2005, I began collecting demographic information from a population of lichens that are growing on tombstones in a Massachusetts cemetery. And the tombstones make this project very poetic, but in fact, I'm using tombstones because they're flat surfaces. And so it makes it very easy for me to see and monitor the lichens. If you traced a lichen on a bumpy surface, like a much more multidimensional surface, it would be hard to get accurate data. So for more than a decade now, I've been watching lichens grow in a cemetery. And I'm doing that because I want to understand patterns of birth. When do new lichens arise from old lichens? How do they grow? How do they reproduce? How does this ecosystem reproduce? And then death. How do they go away? What does that look like? All these dynamics, all these things that we've never thought about quite this way before. So here's the cemetery where I work, and I do have permission to work in the cemetery, and I do, very importantly, have permission from the families of the people who are buried here. And in fact, a lot of the tombstones are tombstones of scientists. So I think that they would like this project very much, and I know I would like to have this kind of project done when I have a big tombstone placed to take up as much space as possible and be as big a habitat as possible for lichens. I hope someone comes and traces the lichens on my tombstone. And these are the names. I'm not going to talk about all of them, but these are the names of some of the tombstones that I work on: Stratton and French and Raup and Gould. And so what have I been doing since 2005? Well, I basically go out with a pen and plastic sheet protectors, so just thin sheets of plastic. And I lay that plastic onto the tombstone, and I make a map of the lichens, and I count them, and I know them. I know the lichens. I know the individuals. I have them numbered. So here's an example of a map that I make. And from year to year, I make maps. For example, you can see individual 20 in the center. And I can watch over time, and here's individual 13 from French, and I can see how this individual grows. And I take lots of notes on this as well. I take lots of notes on reproduction, all kinds of natural history data on each of these individuals. And so how I actually do this then is I take a map from 1 year, I put it up against the tombstone, I mark all the individuals. That's, you see all the little bits of sticky tape there. And then I know what who each individual is. And then I trace them. So then I have a New Year's map, and then I take away all the sticky tape. So for most of the year, you wouldn't have a sense that there was anything going on in the cemetery. Although when I'm actually working in the cemetery, people often stop and ask me what I'm doing. And I can see individuals when they're very small. Sometimes people want to know, can you really see a birth? And I think the answer is yes, I can really see a birth. I can see that individual when it first appears. All right, so what do I get out of sitting in a cemetery and watching lichens grow over the years? Well, I get data that looks something like this. And here you're looking at individual 6 over time. And you can see it grow. Now that's more than 10 years worth of data that I just showed you in I don't know how many seconds, but it gives you a sense also of how unusual it is to have these kinds of data, because it takes a really long time in terms of a human lifespan to try to get a sense of how things are growing. But that's the kind of data I have. And then I try to use it to understand something about lichen growth, always keeping in my head, what am I watching grow? Is it the fungus that's controlling the dynamic? Does it have something to do with the algae? What's going on here? And so it turns out that there's a bit of an answer to this. So when you think about how a lichen grows, it's really two-dimensional, right? And so you're seeing a drawing with radius and height. And when the lichen first appears, it's just that little bump in the middle. So that's the little bump enlarged. And then over time, it gets bigger and bigger, but it doesn't grow so much high as it grows wide. These are sort of flat, paper-like structures, if you will. So that's an older lichen. But it turns out that patterns of airflow are really different around small, rounder objects versus larger, flatter objects. And that's critical because remember, I told you that there are algae in the lichens, and those algae suck carbon dioxide out of the air and fix it. And that's how a lichen builds itself. It builds its biomass out of the carbon dioxide that it pulls out of the air. So just from first principles of airflow around objects, never mind if they're living or not, it turns out that you can build a model for how a lichen grows. And what you're looking at is how a lichen should grow as it gets larger. So, and you see there's a curved bit, which would correspond to a very small lichen. And then there's a flatter bit that would correspond to a larger individual. So this is you could think about it as growth rate through time if you want. Well, it is growth rate through time. So this is just a model. It's data free. It's just a model. But it turns out that if you fit those data that I've been collecting to this model, it works really well. And there are lots of ways that you can think about this result. But what I think is one of the more interesting ways to think about it is that we've discovered an emergent property. This ecosystem that we're looking at of fungi and algae and bacteria seems to have a behavior, if you will. There's a very regular pattern, a predictable pattern to how it grows. And maybe you can think about another ecosystem that you're familiar with. I don't know, a forest or a coral reef, and ask yourself whether it might have the same emergent properties or not. What's unique about this that we're looking at? What's not unique about it? But it gets a little more complicated. So I've shown you my very cleanest data. And what you're looking at here is an image of some of the tombstones, but in front are the more complicated habitats, right? And if you look at the lichens growing on these more complicated habitats, this stone wall in front of the cemetery, it's a mess. It's really hard to see what's going on there, how many individuals there are, how many lichens there are. And this is a real dynamic that one has to grapple with. And here's one way of grappling with it. So here's an individual in this very blurry photo before I had gotten my good camera. And this is an individual labeled 20, and it's actually on Gould. It's right underneath the O of Gould. And I noticed that between November 2005 and May 2006, something happened, it fragmented. So if you were counting here, maybe you would count one individual. But if you were counting here, maybe you would count 3. But how does that work? If at a different time point, you get a different answer. And so I closely followed this dynamic over time. And actually, things started to happen, right? These bits grew towards each other. And eventually, by September 2008, this lichen looked just like one individual. It looks like an entity. It looks like one thing that you would count. If you hadn't followed it over time, you might never know its history, and you might never know that it was complicated to look at. So this is another thing I think about all the time. But it turns out that there's a real history of thinking about fungal individuality, although actually mostly people didn't describe it just that way. And one of the earliest thinkers about this was this very eccentric person named Arthur Henry Reginald Buller, who lived from 1874 to 1944. And there are lots of stories about him, really many stories about him. He self-published all his own work so that he didn't have to face criticism from anyone else. He could say whatever he wanted. He didn't go through peer review. But one of the things early on that he put out there is that when spores, what you're looking at in the top left is spores, when spores germinate and form these young, what are called mycelia, when the mycelia meet and touch each other, they'll fuse and they'll cooperate. And very specifically, they'll cooperate to reproduce. So what you're looking at there is a bunch of spores that are germinating and fusing, and they're cooperating to create one mushroom in this case. So this is a mushroom. And so Buller really firmly believed that fusions are common among individuals, no matter what. And this kind of thinking still dominates, I would say, thinking about fungi and how they behave and interact. And I just showed you, actually, I just showed you something that looks like fusion. But remember that fusion has to do with an individual that fragmented and broke apart. And so when those fragments met up with each other again, they had been the same individual at one point. And for a moment they weren't, and then they grew back and they seem to have become one individual again. Here's another pattern. This is a leaf, and this is a different pattern from this idea of fusion between two individuals joining and meeting up and fusing again. You're looking at a leaf, you're looking at a leaf, and it's like a holly leaf. You can see the edges around it. And it looks like a map, right? It sort of looks like a map of US counties sometimes to me. And what's going on here is that an individual fungus has met another individual fungus, and they've had a war, and they're battling for territory. So each of those polygons, each of those shapes that you can see is actually one individual. And in this case, when one individual meets another individual, they're not genetically identical, would be the way the thinking goes. And so they recognize an other. It's not self, they're not fusing with self, it's an other. And there's a battle. And they secrete chemicals, compounds to stake out their territory. And those black lines that you see, the name for them, they're called zones of antagonism. And so in this way, this is like the holy grail of mycology, at least for me. You can see all the individuals made visible by the wars that they're all having with each other and the territory that they're capturing. And by the way, the black dots that you can see, that's reproduction. That's an individual who sucked enough resources out of its little polygon of a leaf that it's shifted its strategy, if you will, from growth to reproduction, and so it's making spores. So I'm giving you two very different views of how what we might call individuals would behave when they meet each other. One is fusion, and the other is warfare. And so how should we think about lichens? Where I've shown you fusion, but we know from the history of that fusion that it's really self meeting self, and a very particular kind of meeting up and joining. And if you watch enough lichens, it turns out that there's also warfare. So if you look at the panel labeled A, look where the arrow is. The arrow is very specifically one marks, and you can kind of follow the arrow to the right and the left, and you can see an edge there. And that edge is very specifically where one lichen, Raup 25, is overtaking another lichen. So they're having a battle. And in the panel labeled 14.2, you can see, and in this case, it's helpful because the lichens have really different morphologies. You can see again that there are two individuals, and they're duking it out. And actually, what I've noticed is that when this happens in these contexts, the lichens start to grow more quickly in the opposite direction away from the individual that it's doing battle with. In other words, it can't make it very far into the territory of the other. So it starts to take over empty space, empty rock. In that image of 14.2, you might also notice on the top, that there's what I call a black crusty lichen. And there's a bit of warfare happening there too, with the green lichen, Route 14, growing around the black lichen. So I don't particularly have a simple answer for you. These aren't simple systems. And they're very clearly both ecosystems and individual. So that's a challenge to how we think. If we're used to watching birds, I'm still a secret bird watcher. If we're used to watching birds, I have to say that birds, by contrast, seem simple. I can count birds, and when I'm counting birds, I more or less know what I'm counting. But when I'm counting lichens, it's still something that I'm thinking about a lot. What am I counting? What is it? How does it behave? It has a behavior. Is it an individual? What happens when it meets something else? All right, so I hope I've given you a lot to think about, and just a lot of really different kinds of information. There aren't a lot of mycologists in the world. If you're a young person listening to this, we need you. We need more mycologists in the world. By comparison to a lot of other and a lot of other groups, there just aren't a lot of us, and there's a lot of really exciting stuff to do. And with that, I think I'll just say thank you. And I wanted to thank my collaborators, especially doing the work of lichen modeling. That was a real team effort. And also thank my very patient laboratory that tolerates a bit my obsession with lichens. And with that, I'll just say, yeah, Joe, thanks again. It's just it's been so fun to be a part of this.
Oh, Anne, thank you so much. Thanks for coming, representing the fungi, the lichen. Yeah, couldn't be more excited at all about that. So why don't you come back from that screen share so we can get you for a few questions?
Sure. Okay. All right. I've stopped the share.
Perfect, perfect, perfect. So what I want to do is a quick little shout out. I'm looking at our analytics right now on the site, and it's just awesome to see so many groups joining us. Obviously a big group in the US, in Canada and Mexico, but we've got other groups in Australia, Switzerland, Norway, Cayman Islands.
Wow.
So it's so awesome to have such a, an amazing spread across the world taking part in these events and learning more about biodiversity. It's just tremendous. And I think you've really kind of switched some people on about what we think about ecosystems. We're always taught about the larger ones, like the forests and the river ecosystems and things like that, ocean ecosystems. But the little things going on, the smaller battles happening on something like a tombstone are fascinating.
It is definitely, it's the very definition of biodiversity in your backyard for those of us in places like Wisconsin, which I certainly don't think we necessarily the first thing that comes to mind when you think about biodiversity, but there's a lot of it.
Yeah, absolutely. It's that's a great plug there for our backyard bio that we're trying to do right now. Get people outside, taking pictures, getting low. Sometimes your backyard might not look like there's a lot of life there, but if you get low, if you get into the grass, if you really look around, there's a lot you can find. So I hope we see a little fungi and lichen action.
That's the most common feedback I get after I teach classes in mycology. People say, I see them now. I see them now. And it's as if you can't quite see it unless someone teaches you how to see it. But when someone teaches you how to see it, then it's there. It's present for you.
All right. Very cool. So I've got a question. Stephen's tuning in the UK, and he's curious about if other microscopic creatures, maybe like rotifers or tardigrades, play any role in the growth of lichens.
I don't know, but my strong suspicion is yes. I've never looked for anything like a tardigrade inside a lichen, but there are actually lichens are remarkably well known compared to other groups of fungi. I'm going to call a lichen a fungus for a moment. There are about 35,000 of them. But that's probably an underestimate, but there are tens of thousands of them. And I love questions like that because the answer is always yes. Somewhere in those 35,000 species of lichens, there's a tardigrade that makes a lichen a habitat. You just got to go find it.
Yeah.
And that would be a great story.
Yeah, and I think that's the amazing thing about a field like this is there's so much left to do and so much left to discover. I think good science happens when you go out in the field with like 10 questions and come back with 100 or 1,000, because that's just the nature of it. And I don't know is a good answer because there's so much left for us to figure out. All right. So we talked in your intro a little bit about, birds being kind of an intro to getting out and exploring a little bit. Is there a moment, an aha moment when you realized, you know what, I need to pay a little more attention to this group?
For me, you mean personally?
Yeah.
Well,
Yeah.
when I was an undergraduate, I started looking at cooperative associations between plants and nitrogen fixing bacteria. And that, I would say that that was the start of the wormhole. Once you maybe that was my moment where someone taught me how to see. Once you're aware that there is that kind of biodiversity, once someone enables that for you, I found it's really hard to go back, because biology sometimes I feel like is an exercise in, you know, your first year of biology, you're taught a lot. And then in your second year of biology, you're taught that your first year was all lies. And then the more you go on, the more you realize that, you know, the textbook, whatever the textbook was that you had in high school, is really based on just one group of organisms. And if you diverge outside of that on the, you know, around the tree of life, if we built our textbooks just on bacteria, for example, or like starting with bacteria, they'd be written very differently. And so, yeah, anyway, so that's how I got started, was working with and then I got really interested in the evolution of cooperation, and lichens are a pretty fantastic subject for that. They're hard to work with in the sense that you can't bring them into the laboratory and do much of anything with them. My favorite story about that is someone who was trying to grow a lichen in the laboratory, got called up for World War II, and he just abandoned all his experiments on the what I imagine the edge of a windowsill. And then when he came back, one of them had made a lichen. But that's that's a hard kind of way to do science.
All right. Well, what I loved about your talk today too is your passion. And it's great to see people who are passionate about something, committed to something, and learning more about it. And that kind of passion is infectious. So thank you for infecting us today with some of your passion. It was an absolute blast to host you today, and definitely have my mind spinning, and we'll be paying a little more attention when I'm out on my walks to take a little look at that life of lichens and what they're up to.
Great.
All right. Well, thanks so much.